Mhm. Let's talk about systems of inequalities. Before we look at systems of inequalities, let's start by taking a look at linear inequalities in two variables. A linear inequality in two variables, namely x and y, is written in the form that you're looking at. Notice the structure is very much just like linear equalities. The key word here is inequality. So the inequalities that we are looking at could be less than or greater than or equal to, or let's see, less than or greater than, less than or equal to, and greater than or equal to. There is a fifth inequality, not equal, but we're not interested in that. Okay, so this would be the linear inequality. So let's see how we actually solve the linear inequalities. Now, the way we solve them, by the way, in this course is by geometrical, by graphing. Not geometrical so much, but graphing method. So let's begin with an example. Suppose I want to find the solution to the inequality x plus 2y less than or equal to 6. Okay, so our first step is to pretend that this is an equation. Forget the inequality, regardless of what it is. Less than, greater than, less than or equal, greater than, equal, doesn't matter. So we're just going to go as if it's an equation, and then we're going to graph this equation. You can graph equations at this point any way you want, plotting points, writing in slope-intercept form, but however you're comfortable. The way I do this, usually if the equation is in standard form, I like to actually use intercepts to graph the inequality or the equation for this matter. So I'm going to let x be 0. When x is 0, then y must be 3, because 2 times 3 is 6. And then separately, we're going to let y be 0. When y is 0, x has to be 6. So this will give me the 2 points that I need on the graph of this line, which helps me graph the line actually. Now, 0, 3, call this 0, 3, and 6, 0 would be this point. Next step, we connect a line through these two dots, and there you go. That would be the graph of that line. Notice we have not taken into account the fact that this is an inequality at this point. Now, once we have the line, let me label the key points. That was 3, this 6, and here's my 0. So our coordinate system is labeled accurately. Now, once we have graphed the line, here's where we're going to now actually take into consideration the inequality. So let's actually do this. Next step is to pick a test point. Okay, a test point is a point of your choice. The only restriction on test point here is that we're not allowed to pick points that are on the line itself. Nothing on this line, nothing there. Okay, and you will see the reason. I'll explain in a moment why we are not allowed to do that. In fact, we'll do it. They say don't do it. We'll do it and see what could go wrong possibly. So let's do our test point as long as it's not on the line. So the easy test point, unless the line goes through the origin, for me is 0, 0. So I'm going to pick test point 0, 0. Your test point is actually a proposed solution to the inequality. So we're going to plug in for x into the inequality now. Plus 2 times 0 less than or equal 6, which means 0 is less than or equal to 6. At this point, we look at the truth or fallacy of that statement. 0 is, we know it's not equal to, but it is less than 6. So this is logically a true statement, right? Because 0 is less than 6. It is true. If it's true, that means 0, 0 is one of many, in an infinite set of solutions, is one of many solutions. So to include this test point, which is 0, 0, I need to shade a region on the plane. And there you have it. So the solution, notice, is a graphical solution. Graphically, where you see this hatching, the red hatch, And you can see that that's the solution. Every ordered pair, any point on the plane that is below the line. Notice, by the way, the line divides the plane into what we call a half plane. That is a half plane. The other half is above. So one half is below, the other half is above. That's the idea behind labeling it as a half plane. So the solution is a half plane. Now the line itself is, which is the boundary, if you will, of this region, could also be part of the solution here, right? Because 0, 3, remember, that's how we started to plot these points. 0, 3, if I plot that point, or if I plug it into in my inequality rather, x is 0, 2 times 3 less than or equal 6, 6 is less than or equal 6, and that is true. So notice 0, 3 is a solution, so is 6, 0, and so will be any point on the line. So there you are looking at the graph of this inequality. Now I mentioned the reason they say do not pick a test point on the line. Let's do that. So here, this was my line, right? And this one point on the line, for example, was 0, 3. So let's choose our test point to be 0, 3, when what they say we don't have to do. Now plug in 0, 3 into inequality, we get 0 plus 2 times 3 less than or equal 0, 3 less than or equal 6. And of course we get 6 less than or equal 6, which is precisely what I have up there, right? Just going through the motions here. All right, so that is a solution. And this is my point. Now the question is, how am I going to shade that half plane? Which side of the line am I going to shade? See, if I'm on a line itself, anywhere, any points on the line, I'm on the line. I cannot go in either direction here. I don't know which direction to go. So that is the reasoning behind not allowing test point to be a point on the line itself. And there you go. We're done with this inequality. Pretty easy. All you have to do, remember, to graph it. Now let's take a look at another one. Another linear inequality in here. This next example. Suppose I want to do 5x less than. This time I'm not going to go less than or equal. We're just going to go less than. All right. And I'm going to bring the 4y to the other side. Turn it into standard form. There. That's optional. And then I'm going to do this as if it's an equality. You see that? Regardless of the inequality. Now, again, going by what I just said, once I have my equations in standard point, I like to choose intercepts as my points on the graph of this line. So here's the line, the coordinate system. Now, when x is 0, y, let's see, negative 4y is 2, divide both sides by negative 4. So y turns out to be, yeah, divide both sides by, remember, I'm doing here, and also it's important that this is negative 2. Makes a big difference, doesn't it? All right, divide by negative 4 both sides, so I get 1/2. Make a long story short. And then another, separately, I'm going to let y be 0. So when y is 0, divide both sides by 5, and I get x is negative 2/5. All right, and there we have it. So x is 0, y is 1/2. That's this point. X is negative 2/5. Negative 2/5. Let's make it that. It's not drawn to scale because I know negative 2/5 is less than 1/2. Maybe I'll make this point a little higher, just so it's a little more to scale. All right. Yeah, this should be adequate because that's just 1/2. All right, negative 2/5. So next I need to draw the line, correct? And that would be the line. Now, if I plug back these points, for example, 0, 1/2, into my inequality, 5 times 0, negative 4 times 1/2, less than negative 2. See, now we're looking at the inequality. 5 times 0, of course, 0. Negative 4 times a half is negative 2, less than negative 2. Now, what do you think? Is negative 2 less than itself? So that would not be a true statement, true? So this would be false this time. Now, had this been less than or equal to, that would make it logically a true statement because it's equal to. But at this point, strictly less than, that would be false. Therefore, the point that's on the line actually doesn't work, right? It gives you exactly equal to. And it's because of that we're going to make this line, we're going to turn it into a broken line, a dotted line, or a dashed line, however you call it. And that's what this one is. And we have the line. So that takes care of the boundary, so to speak. So no points on the line so far. We don't have a solution. Now, we need to shade a region. The half plane is what we're looking for. So for that, I'm going to choose my test point. And again, for all practical purposes, test point, the origin. Unless the only time 0, 0 doesn't work is if the line goes through the origin, because that makes 0, 0 a point on the line, which I'm not allowed to pick. And in these cases where the line runs through the origin, the next best point is maybe 1, 0 to pick for a test point, or 0, 1. I would like to have 0 in there as much as possible, and then closest thing to being a nice number to work with after 0 is 1. And there you go. These would be my choices for test points, provided the line goes through the origin. So for this one, I'm going to stay with my 0, 0. It's been good to me. It's worked. Why not? And let's plug in 0, 0. Where are we going to plug it into? The original inequality. Well, the original is that, but remember, we just moved 4y to the other side, so still the second one would do. So I'm going to go 5 times 0, negative 4 times 0, less than negative 2. Left side is 0. That's why I like 0, 0. Is 0 less than negative 2? Well, that's not true, because 0 on the numbered line is to the right of negative 2. Correct? Here's 0. That's negative 2. Numbers increase as you go from left to right. Correct? So 0 is greater than negative 2. Okay. This is not true then. 0 is less than negative 2. No, that's false. If it's false, that means 0, 0 is not a solution. Therefore, this is not a solution. Well, if it's not the solution, then nothing on this side below that line is going to work. That means our shaded region, our half plane, is going to be a region that lies above the line. And there we have it. See how that works? And we are good with this one. Again, the solution is a half plane. If it exists, that's what it is. In the case of a line, if you have a system, it would be different, may not be a half plane. But for now, this one is also a half plane, the way you look at it. There are actually algebraic methods for solving inequalities also, but we don't look at those in this course. We just look at graphical methods. Okay, let's take a look at another example. This example, I'm going to make this a nonlinear equation. Let's make it easier. X minus 4 squared plus y squared. Let's go greater than or equal 9. Now, if you recognize the form of the equation, because we've seen these before, x minus 4 squared plus, I'm going to go y minus 0 squared equals 3 squared. Most of you probably recognize this as an equation of a circle whose center is 4, 0, right? HK, remember the HK form of a circle? This is the HK form of a circle. X minus h squared plus y minus k squared equal r squared. And the radius, of course, is 3, square root of 9. So I can actually graph this circle now. Okay, and let me graph it real quick using my note. All right, so here I have the graph for you. And the way I graph this, is, I know the center is 4, 0, so correct, that would be the center, which is at 4, 0, x4, y, 0. The radius is 3, so the radius of this circle is 3. That's why I go to the right, and I get 7. I go to the left, land on 1. Okay, so that's how I got these to come out. Okay, and then once I have the graph, now let's do this inequality. The boundaries of the circle are part of the solution here. Correct, because any point on the circle will equal to 9 here. I mean, when you do x, y, when you do this left side, you get 9. And let's do our test point and see how do we shade this region. Notice we no longer have a half plane, because this is not a linear equation. So my test point, as long as it's not on the circle, that would on the circle, that's fine. You're welcome to go 0, 0, or I can actually go with this one 4, 0. We try both of them. Remember, it doesn't matter who picks a test point, we all end up with the same conclusion. So you can pick 0, 0, you can pick a point above the line, below the line, doesn't matter. As long as the statement is true or false, that's what makes your decision on how to shade. So let's go 0, 0. In my original inequality, that's going to be 0 minus 4 squared plus 0 squared. 0, 0, of course, makes it the easiest, right? Negative 4, 0 minus 4, negative 4 squared is 16, plus 0 remains 0. Is 16 greater than or equal to 9? This is true. If it's true, that means this is a solution, right? Well, if that is a solution, therefore everything outside of this circle is going to be a solution. You notice we do not have a half plane. We have an entire plane, the entire coordinate system, except what's inside the circle. Now, let's say my test point is 4, 0. Suppose my test point is now, I'm going to change it to 4, 0, the center of the circle. Plug it in. 4 minus 4 squared plus 0 squared. Is that greater than or equal to 9? So I get 0 is greater than or equal to 9. Well, is 0 greater than 9? Definitely not equal to, but it's not greater than 9 either. So this is false, right? Well, if it's false, that means this point is not a solution, right, inside the circle. Well, if that's not a solution, then that means everything outside of it has to be. So we end up shading exactly the same region on the outside. So that's what I was saying. It doesn't matter who picks the test point, as long as it's not on the boundary of that shape. The decision and the conclusion on how to shade will remain the same. All right, done with this one. Let's take a look at a couple more, and then we'll be done with this. Let's try, I'm going to try another non-linear. Oh, let's actually do a system now. Let's talk about system of inequalities. Just like we talked about systems of equations, we're going to look at systems of inequalities. Now, this time with systems of inequalities, anytime we have 2 or more inequalities, then that creates a system. And just as with systems of equations, we looked at systems of linear, nonlinear equations, we're looking for the common solution to both inequalities. And because we're doing this graphically, so it does require that we graph 2 regions now, and then we go from there. So looking at this one now, let me again graph my circle real quick, and then I'll graph the line also. All right, so here we have the graph of the system, and I'll show you again how I did this. The x squared plus y squared equals 9. Remember, we always start by assuming that these are equalities. This one we recognize again as a circle whose center is 0, 0, and the radius is 3. So that's why I have center is 0, 0, and the radius of this circle is going to be 3. So from here to there is 3. all these distances are the same, equidistant. So the radius is 3, and so is this one, which makes this component, the x component, 3. And so we have that one. Oops, I didn't mean to do that, sorry. There you go. And it makes the y component also 3. So that's how I did the circle. Now, because the circle is less than, right? The equation, the inequality is less than 9. So these are actually the outline, the boundary of the circle. These are going to be dotted lines. Okay, so that's what this one is. And the line. Let's take a look at the line here. So we have an equation that is 3x plus 5y equal 15. To graph the line, we set it equal to. And then remember, I like to go with the intercepts. So let x be 0. When x is 0, y must be 3. And then separately, we're going to let y be 0, x would be 5. And that's how I got this point. That's 0, 3. And this other point, this would be 5. Okay, so we are good with this one now. So that's how I graph the line. The line will be solid, right? Because you have equality in there. Remember, if the equality is part of your inequality, solid line. Let me put that. For less than or equal, greater than or equal, the line or the boundary of, if it's a circle or whatever the other shape is, will be solid. But if we have less than or greater than, the boundary is going to be dashed or dotted. The line would be a dotted line. All right, so we're good on this one. Next, we're going to move to our test point now. The test point for the circle, or this one. Our test point, I'm going to go 0, 0 as long as it's not on both shapes. Test point 0, 0. I'm trying it in the circle. So 0 squared plus 0 squared is less than 9. 0 is less than 9. And that is, of course, a true statement to make. True. And there it is. True. So 0, 0 is a valid solution. With respect to the circle, I'm going to shade inside the circle. And notice even reaches above the line because that region is all inside of the circle, even outside this portion that lies above the line, the interior of the circle. Now, for the line, let's do my test point. Same test point. This time I'm going into the line. So this was a circle. Now I'm looking at the line. For the line, I'm going to go 3 times 0 plus 5 times 0 less than or equal 15. 0 less than or equal 15. Again, this is a true statement. So 0, 0, the origin, also is a solution to the line this time. And for the line, I'm just going to change my shading. I'm going to go in a horizontal direction. Doesn't matter, you can shade below. It's just this illustrates what I'm about to illustrate a little better, right? So this is what it's going to look like. Perfect. Now, the region, the solution is going to be a region where the two shadings cross. So they will cross right at the in the middle, right on the interior, on the inside of the circle. This part is not part of the solution because it's above the line, right, with respect to line. And anywhere, like all of these, this portion here and this portion here, everything outside of the circle is not going to work as a solution in the circle. Therefore, the crosshatch here is going to be the final solution to this. Okay, so I'm just gonna do one way of shading here for you to make it look nice and clean. And there you have it, like magic. All of a sudden it appeared. And there, So all I did again was use the crosshatch down here, and that is the final solution to this inequality, system of inequality. Let's take a look at one last one maybe. In this example, suppose I have x plus 2y less than or equal to 4, and then let's go with a parabola. How's that? Y equal x squared. Let's make that greater than or equal, so it's easier for me to draw them using my software. And there you have it. So let me graph the line first. X plus 2y equals 4. I'm going to plot points. 0, 0 for x, y intercepts, right? When x is 0, y is 2. So that would be your y-intercept. The x-intercept when y is 0, x would be 4. And that is my, again, x-intercept. So I'm going to draw this by hand, and then if it doesn't look that good, I'll draw it using the software. But for now, I think this should be okay. So x0, y2 would be here, x4, y0 would be there. Solid line, and here is the graph of that line. Okay, that's the graph of the line. Now my test point, I'm going to go 0, 0. Again, that's my proposed solution, a point at the origin. And for this one, let's see, plugging 0, 0 into inequality now. I have 0 plus 2 times 0 less than or equal 4, which means 0 is less than or equal 4, and that is a true statement. If it's true, that means my proposed solution is a good solution. Therefore, we're going to shade below. Now, for shading below, by the way, there is a better way to shade so the crosshatch doesn't get confusing. Instead of shading below like this, which is fine, let's just put an arrow at the end points. Okay, at the end point, near the end point, because remember the line is infinite line. It goes indefinitely in both directions. So rather than shading, I'm just going to put arrows, and the arrow means what I just erased or removed. So everything below the line so far. Now let's look at the other equation. The other one is a parabola. The graph of parabola, remember y equal x squared, that's the basic parabola that looks like this, and that's x squared. X squared minus 1 will shift this down 1 unit and you redraw it. True? That would be shifted down. So that's x squared minus 1. Now that's what I'm going to draw. The x-intercepts, let's see, when x is plus minus 1, y would be 0. So those become my intercepts. I'm going to make it go through here and through here. So I get something that roughly looks like this. Okay, that will be the graph of that parabola. It will be a solid boundary because equality is included in that inequality symbol. The low point here is -1 and 0 the origin. All right, now let's take a look at the region for the parabola. So I'm going to go test point into my parabola. 0, 0 is inside of the parabola. 0, 0. That makes it 0 greater than or equal to 0 squared minus 1, or 0 is greater than or equal to -1. Well, that is a true statement. Again, not equal to, but 0 is bigger than -1. Well, if it's true, that means I need to shade inside the parabola. And that would be inside the parabola, right? Okay, so since I'm using arrows, that means everything in that formation, right? Everything that's inside. So imagine inside the parabola, outside the line, the region of intersection, clearly it's going to be this region now, right? It's going to be this one. Below the line, I want to make sure I'm staying below the line, but I'm inside the parabolic region. And there you have it. That would be the solution to this inequality. Again, our solutions are graphical solutions, and it's really as easy as you just observed it. This is not complicated, so I hope you find this doable, you find it manageable and easy to follow. All right, we are done with this video. As always, thank you for watching.